Hi everyone, welcome back. And today we will be solving another problem from our SD sheet DP section. So this is a very important problem and frequently asked in interviews, that is longest common subsequence. So we have been solving few problems like longest increasing substring or subsequence, I think was the one we discussed yesterday. One question we have already done is longest common substring, if you guys remember. So if you have gone through that lecture, right, the substring one, this will not be very difficult. If you are directly attempting this one, it might take some time for you to understand. I'll suggest go through that and then you try to attempt it. Both are, at least you'll get the intuition behind the problem. I'll just check if I'm live. Yes, I am. Okay, so let's understand the problem statement. What you have to do is you have to find the length of longest common subsequence in the two given strings, right? So by now you should know what is substring or subsequence, because I have repeated this a lot of times in my previous questions. Let me take another example. We'll take another example. For example, I'll take string 1 is A, B, C, D, E, and let your S2 string to be ACE. Let's understand with this problem. So first of all, how will you find subsequences, right? The very brute force approach I've discussed in during substring. So just go through that. Will not be repeating the same thing. Let's directly come on to how are we going to generate subsequences from these two strings in such a way. Let's understand it first. How are we going to take it? You can see that wherever I find A here, I find the same character here. Subsequence need not to be consecutive, right? The characters need not to be consecutive. Wherever I find a match, it will add up to my subsequence. So at least A is one of the common subsequence in both the strings. Talking about B, no. Talking about C, yes, C is there. D, no, D is not there. E is there. So I can say that ACE is my subsequence and the length of it is 3, and you'll realize, and for this test case we'll have this as a maximum length of any subsequence that we will get from S1 S2. What are the other possible subsequences? For example, just A is also a subsequence, but its length is 1. If I want to take AC, AC is also a common subsequence in both the strings, but the length is 2, and we have already a greater length than that. Another can be your CE. C can also be one of the subsequences, again of length 2. So I'm just showing you some examples of subsequences. Among all the subsequences, these are not all, these are a few, we'll get the longest subsequence will be of length 3. How can we do it? So let's understand the recursive tree first of all, then the things will be clear to you. So if I started in this way, guys, you can try it in any way you want to match from the beginning. Try matching from the beginning. Okay, let's just take it from the end. What I want to take from end is, for example, let's start iteration from the last characters. Again, I'm saying if you want you can start from the beginning, but you'll see what kind of approach we are going to do here. So if I see I have two strings, let me write them again. A, B, C, D, E. Other string is A, C, E. Fine. I'll check the last characters. Last characters are E, E in both the cases. In both the cases, I have found this character and this character are matching. So now let's shorten my strings. I have already found one subsequence whose length is 1. Okay. Let's find out if reducing it from my string, what is the remaining string? A, B, C, D from here, and from here what I'll get will be AC, right? And I will already add 1 to my answer because I've already got 1 because of the matching characters. Once the characters are matched, now I'll find out the matching characters from the remaining part of the string, right? So this is my remaining string. Now what I want to do, I will again do the same thing. In this remaining string, I'll check the last character. D and C, both are not matching. So although they are not matching, what can be the other possibilities to match? Let's take the remaining part of this string by removing D. What if in this remaining string I find a match with AC and I'll keep AC as it is. Other possible case could be, see, whenever there is a mismatch, we discussed in longest common substring also, whenever there is a mismatch you have two options, right? The options are, there is a mismatch here for sure, but doesn't mean I will just compare by removing both the characters from the end of their respective strings and I'll compare like this. No, what if this is a mismatch for sure, but what if this becomes a match with this? For example, if it was D here, for example, so D and D in this case would be a match, right? So I just have to find what are the matching characters in any part of the string. The order has to be maintained obviously, but it can be present at any index of my string, so I have to explore all those options. Let me know. This is the reason we are finding more possibilities whenever there is a mismatch. Okay, and here the possibilities are, once I saw the remaining, I am checking for the remaining part of the string by removing D and keeping the other one same. Other possibility is that you keep this string as it is, A, B, C, D, and match it by removing C from the end. So I'll get A as my remaining part of the string, right? It is going to be AC only. Next, what? Next up I have, I'll just use one kind of a, okay, now whenever there is a match, obviously I get 1 for that, 1 as my answer for that, because there is a match. So I'll omit C and C and check for the remaining part of the string, which is AB. I'll compare it with A. Let's check the other case also. It's a mismatch, so again there will be two possibilities. One, that you remove the last character from the first string and keep the other one as it is. Other one is keep the first one as it is, A, B, C, D, and remove the last character. So now you are left with the null string in the other one, and this is what you found here. Let's compare this one. It's a mismatch, right? Whenever there's a mismatch, you got two options. One, you compare first string by removing last character and keeping the other as it is, and the other one is keep the first as it is and compare the other one by removing whatever character was at the end. Now I get an empty string. So wherever I'm finding an empty string, that's I can treat it as my base case, or you can treat it as the end of your calculations. Why? Whenever you get one of the strings is a null string, right, or there are no more characters, so there will be never a match of a character, so you at least know that answer from here is going to be 0. That means the length of longest common subsequence from such a case will be 0. Same for this, you get 0, right? I have, when I found A, and after that I'll remove both the characters, my comparison will be a null with the other null string, so there will be nothing, but this itself will return 1 for it, because I got 1 because of this match. At least one subsequence is what I got, so it returns its answer as 1, this returns its answer as 0. So at this step, what would it like to take? For imagine if your question was for AB, S1 is AB and S2 is A. In this case, AA itself is the longest common subsequence whose length is 1. So what do? You try to explore all the options by reducing your string to just A compare with A, other one AB match with null. So out of all the options, what is the maximum length you are finding? That is what you will choose for yourself. So when at this state, right, it has two options, whether one answer it gets from its left side and one answer it gets from its right side. So it will choose the maximum of both. So 1 is what it will choose and return its answer. So 1, it returns to this state. Now this state has already its answer 1 because of a match here. So it had only one child, right, which returns its answer as 1. So it will take that one and add to its own answer. So 2 is what it will return to its parent. This is how recursion works, right? So 2 will be returned to this state. Now you'll see that it might have gotten some answer from this state as well. So ABC and A, I have to explore the options. So in here I'll get answer 1. I'm not going and creating the further recursion tree here. I know that it's going to be 1, so maximum answer that it will generate is 1. And here it was no match, so it will return 1 only. So you will see that out of the two options that it had for itself, right, it will choose the maximum of both, which is the maximum 2. So it returns 2 to this state at which I started, and the state at which I started, I already had answer 1 for itself because there was a match, and the answer it got from its child is 2. There was only one child that it generated for itself because of a match. Whenever there is a match, only one branch follows because I get rid of both the matching characters and solve the problem for the remaining substring from both the strings, right? So it returns 2. So this 2 will add to its own answer, which is 3. Finally my function will return its answer as 3. This is what we expected also, right? This is what we discussed. So all in all, I hope you got an understanding. Let me just check if my live is as I'm expecting it to be. Yes. Am I not live? Okay. Right. So if you have any doubts in understanding what went here, why we chose this recursion tree, this methodology, see, for any DP problem you just cannot go create an array, solve the problem. You need to have an understanding of this recursion tree in your mind. Only then you will be able to. What is DP? DP is nothing. It's just you're reducing the time complexity of a recursive approach. That's all. You see that at max I have, although whenever there is a match I only have one option, but whenever there is not, I have two options, and such options for, let's say, n number, 2 into 2 into 2 options for example n characters, right? Even if I have n characters minimum, it will be 2 to the power of n. So big O of 2 to the power n at minimum would be the time complexity of such an approach. So nothing, will use the memo. This is known as memoization technique, which I'll be now showing you for DP. There is other one called tabulation. So tabulation, it looks more of something that has been told to you, okay, this is a table, fill the table. It reduces to just filling up the table. But if you understand memoization, you can definitely do tabulation, but I would not suggest that you start with tabulation approach, because it's pretty much like filling the table. But if you don't understand this, how we are filling the table, then it will be a problem. You won't be able to solve other problems on TP. Okay, so if I were to do this with recursion, this is how it's going to end up. Using memoization, I am going to do nothing. Wherever you see there is a repeat of the cases, for example in this question, did I see any repeat of any cases? I think I have not drawn the recursion tree entirely, but I will find it somewhere. For example, here it was not a match. I would compare AB with A, right? And other one would be ABC with a null string. So you see that ABA has been evaluated here also. AB and A I'll calculate again here also, right? I'll make recursive calls for this and calculate its answer, then finally return it. So the use of DP would be that it will minimize the repetitive calls. Once I got answer for any particular state, I will store it into my 2D array, right? How I'll do that, I'll tell you, don't worry. But this is the intent, this is the intuition, that when I move to this DP array, right, I created DP array, it will be a 2D DP. Why 2D, that also you need to understand. So it depends on state, right? When to use 1D array, when to use 2D array, that is also something you need to understand. Can't take up here in one question, because this is something you need to have a little theoretical understanding when you're starting with DP, right? States and everything. So coming back to it, finally let's see how DP is going to solve a problem. Let's take, for example, what was the length of your, we got two strings, right? One is A B C D E. I find this also quite big only. A B C D E. Okay. Other one would be ACE, right? Okay. Other one is ACE. I'll take an extra for the null part. Okay. ACE. Fine. Okay. Next, what I'm going to do, or you can choose to take no need of an extra one. We can choose to take AC. Wait, I'll just draw this table. Okay, now let's start a comparison. How are we going to fill this table? Initially, I'll fill every with -1, okay? If whenever there is, let's say I have -1 everywhere, which tells me that right now I do not have any length of any common subsequence, right? For example, it's -1, and what else? For example, let's start it in this way. Now what I'm trying to do is, let's have an understanding in this way. I am trying to compare. I'll start with the last one, right? ACE, ABCDE. So basically I had, just recall, whenever when we fill this one, just recall the recursion tree that we discussed. ABCDE and ACE. So this state is represented by this block, right? So I'll make a call to my LCS function, for example, LCS function, in which I'm passing strings S1, S2, okay? Other things I'm passing is, let's say, the index at which I am. So initially that I'll be passing would be last indexes of both the strings. So I and j, I will be n-1 and j will be m-1 if their length is n and m respectively. So, and the dp array that I have created, okay? So this is, let's say I am going to pass into my LCS function. What it is going to compare? It will check if there is a match, right? If there is a match, so dp of that I and j will be inserted with 1 plus 1 will be added because it's a match, and then I'll ask what was the answer that I got from LCS. All the parameters will be same except your I -1 and j -1, and dp will be same. What this means is, see, whenever there is a match, I will add 1 to myself. So basically I'll add 1 here, but I'll ask what is the answer that I got when it's a match. So LCS of I -1 j -1 means this is the state of my recursion, that I am comparing AC and ABCD. So the answer for the longest common subsequence for this state should be stored here. Right now it is also 1. So as long as I am getting my answers as 1, as -1, that means it has not been evaluated yet, right? And as long as it's -1, I'll keep going and calculating my answer. So by doing this, when I reach at that state, the moment I reach when my I becomes less than 0 or my j becomes less than 0, you return 0 for that particular state, right? Okay, so for example, when I'm at this state, okay, it's a match, it's a match. So 0, you return 0, and then you add 1 for yourself. So now that is when you will start generating answers, right? You will get 1 for this state, okay, and whichever would have called it. For example, if I was sitting here, I was sitting here, it must have asked, okay, what is the answer for I -1 and j -1 if I make a call to function by passing these as my parameters. So I'll see that I am already at I equal to 0 and j equal to 0. I -1 and j -1 will make my I and j negative. So I'll keep a base case over. Obviously you'll say that whenever your I is 0 or your j is 0, that means you do not have anything to match. In that case, you return 0, because that is when you will generate the answers. Now you will get your answer from like this. So at this state, I saw that the previous call returned me 0, but because of a match, I'll add 1 to myself. So 1 plus that answer that I received from LCS of this I -1 j -1. So this returned me 0, right? So this one got added here. Now this function call if it was called by some other state, that will be filled accordingly, right? So if I write, it's a case whenever there is a match. Okay, if there is not a match, let's go to my else case. Then how would you fill your dp of ij? So dp of ij will generate its answer from max of whatever it will get from this function lcs, passing other parameters as it is. First I'll pass I minus 1 and j, and in the other case I'll pass I and j minus 1. Why I'm not elaborating it enough? Because we have discussed it a lot of times. I'm actually done repeating it number of times, but yes, the reason is I have already discussed that longest common substring, so it's pretty much similar, although there is good amount of difference, but yeah. So that is about it. So let me now show you the code. In case you have doubts, meanwhile you can ask me. Okay, have a look at the code. So what have we done here is, this was a function that was given to you. Okay, this was a function given to you, and we have just made another function by the same name because the arguments are different as compared to the previous one, so the same name will work. Let's focus on this. Initially, as we have written here, I have filled my dp with minus 1 dp array, which indicates that no answers have been generated so far. And then I make a call to this function lcs by passing I and j as the last indexes of both the strings, right? Because I want to generate the answer that I'll get at the last box. This is the last box. It tells me, logically this means that it will tell me the length of longest common subsequence for the strings where S1 is ABCDE and S2 is ACE. For example, if I talk about this box, so this box, after doing all the calculations, whatever will be the answer stored here, if it's not minus 1, then it ideally tells me, logically it means that it will tell me the longest common subsequence between AC and ABCD. That's what it means. Okay, so I hope you understood that what each box represents, and also it's not necessary that every box will have some non-minus 1 value. The reason is wherever necessary, it will make call to those blocks only, right? It's not necessary that every box is evaluated. Getting my point? So for that you'll have to generate the answers for this thing, which you can try it once you understand the code. You can try it yourself and try to fill the dp array, which you will understand very clearly only when you have understood the recursion tree. Okay, so since I told you this was the base case, because when my I becomes equal to 0 and j becomes equal to 0, and for example if it's a match, or even if it's not a match, right, it can land up I being minus 1 or j being minus 1. So in such a case you return 0, right? Because there will never be a match for that case. Why is it not minus 1? Why I'm not returning minus 1? Because minus 1 is for the case where I have not evaluated that state itself. But once I am at that state, I have evaluated, and if it's not a if I'm not getting any common subsequence, then you return 0 for that. So if dp of ij is not equal to minus 1, you return that value. Okay, so this is, let's understand what I discussed here while I was telling you. So whenever there is a match, you are dependent upon your same function by reducing the indexes of both the strings, because you want to generate your answer by getting rid of the ith and jth character from both the strings. And if there is not a match, then you try out both the possibilities and take the maximum out of it. Finally you return that answer. So it's recursive approach. You have to try it on your own again, even if you have understood this, right? So that will be about this question for today. That's all, guys. Then let's wrap it up. Fine. Okay, see you all in the next lecture. Bye.